In this video, I'll be discussing the 2017 AMC 10A question number 25. For how many integers between 100 and 999 inclusive have the property that some permutation of its digits is a multiple of 11 between 100 and 999? For example, both 121 and 211 have this property. Okay, so we want to find out how many multiples of 11 are between 100 and 999. How many integers are between 100 and 999, such that some permutation of this, which means like if you twist the digits. So like for example, in the example shown, 121 and 211 are permutations of each other. They have the same digits but in a different order. But they both have its property. So, first of all, how many multiples are there between 100 and 999? We know that we know that 11 times 10 equals to 110. This is the lower limit. And 11 times 90 equals to 990. This is the upper limit. Because 11 times 9 equals to 99. And 11 times 91 equals to 1001. So now that we know this, how does this help? Well, this can help us to find the total number of multiples. So we can get that there are, how many numbers are there between 10 and 90? Well, it'll be 90 minus 10 plus 1, so that'll be 81. 90 minus 10 plus 1 equal to 81. Multiples of 11 between 100 and 999. When you're trying to find the numbers inclusive between two numbers, you always have to subtract the larger number from you have to subtract the smaller number from the larger number, and then you have to plus 1. So like an obvious example of this is like, if you want to find the numbers from 1 to 10, well, that will be obviously 10 numbers. And that will equal to 10 minus 1 plus 1. So like 10 minus 1 plus 1 equals to 10. So that's why there's 81 multiples, not 80. And using this, well, note that if you have 3 numbers, there are 3 factorial ways to arrange the 3 numbers. So like if you have 3 blanks and you want to see how many permutations for this you can get, well, it'll be 3 times 2 times 1 equals to 6 permutations max. For any set 3-digit number. For the first blank, there's 3 possibilities. For the second blank, there's 2 possibilities. And for the third blank, this is 1 possibility. Note that I said max because, well, this is like without any restriction. And later on, we will subtract the cases like they're invalid, which are like sometimes they don't have 6 permutations. Or sometimes it's not even valid because 0 is like the first spot after permutation. But right now, we're just saying 6 for overall. So then you'll get that 6 times 81 equals to 486. Now, don't fall the fourth trap because it might be very tempting to just circle E right now, but this is wrong because you have overcounted. Why? Well, because some numbers, here's what I mean. Let 11 be a factor of ABC. Well, what is the divisibility rule of 11? we know that 11, divisibility rule of 11, if 11 is a factor of a plus c minus b, then 11 is a factor of a, b, c. But as shown here, if you just take 121 for example, a plus c equals to 2, minus b, which is going to be minus 2, so that'll be 0. So when a plus c minus b is 0 or a multiple of 11, then ABC is a multiple of 11. However, there's a loophole here, because as you can see, C and A can be switched, because if 11's a factor of ABC, then 11 is a factor of CBA. Because you see, if A plus C minus B is a multiple of 11, then C plus A minus B is still a multiple of 11. We just change the order of A plus C. And then by the commutative property of addition, A plus C equals to C plus A. A plus C equals to C plus A. So you see, in a single permutation, we have two duplicated ones. So this is why we can't have 486 as a total. Instead, for the first step of subtracting or counting, we divide it by 2. 243. Because there's actually only 3 usable permutations for a number. And this 3 is only saying that if all 3 digits are distinct. So like, if A, B, and C are distinct integers, there's going to be 3 permutations, not 6. So for example, you could take 143. Example, 143. Well, the permutation of this can be like 341, 413. Well, you see like 143 and 341 are both multiples of 11, which is repeated. And then like 413, and then 314, and then 134, and then 431. So these are the 6 permutations of 143. But then 314 and 413, 134 and 431. Well, you see by like this one, we just switched 4 and 3, the order of 4 and 3. And you also switch the order of 1 and 4. So there's actually only 3 permutations. So like we can take 143, 413, and 134, and the other 3 won't count. Okay. And then, after we get 243, there's still not a final answer. Because, you see, if you just have another example, like 220, well, 11 is going to be a factor of 220. Then, well, this thing doesn't even have 3. This actually only has 1. The 220, because like 220 it can be permutation like 022, 202. Fine, it has 202 as one. And then it has like, and then it has, well, 2 and 2 can be switched, but it's going to be the same thing. So these are the 3 permutations. But then of these 3 permutations, well, 022 doesn't work, because 0, as I said earlier, 0 cannot be in the first, cannot be like the 100th digit, or else it's just going to be 22. So this means that the actually total number of integers will be even less than 243. And now we can use a trick, like we can just use the answer choices. So the only answer choice less than 243 is 226. So the answer will be 226. The key part of this problem is that, well, first you have noticed that there's 81 multiples of 11 between 100 and 999. Then, you see, there are 6 permutations for each number. There's 3 times 2 times 1. So 6 times 81 equals to 486. But then the trick with this problem is noticing that ABC, if 11 is a factor of ABC, then 11 is a factor of CBA. So this means that you have to divide 486 by 2. I show an example here. 41331, 134, 431. There's permutations all contain 143 and 341. And this is a duplication, so you have to divide it by 2. And then since 11's, and then also after dividing by 2 you get 243. But then as shown in the another example, 220 permutations are 022 and 202. Are distinct permutations. But 022 is not possible because it's only a 2-digit number, because the hundredth digit is 0. So then it'll be even less than 243, the total number of integers. And now we can just see that in the answer choices, there's only one answer choice less than 243. That's 226. So we don't even need to calculate the exact number. So that's how you solve this problem. Thank you for watching.